Hey guys, welcome back to Michelle's STEM Journey. I am Michelle and I'm here today with another AMC Problem of the Week video. This week's video comes from the year 2010, 10A Problem 17, and it deals with geometry. I hope you all enjoyed this video and let's get started. The problem states a solid cube has side length 3 inches. A 2-inch by 2-inch square hole is cut into the center of each face. The edges of each cut are parallel to the edges of the cube, and each hole goes all the way through the cube. What is the volume in cubic inches of the remaining solid? Okay, so I drew out the cube and it's not the best, but you kind of get the idea that like the red parts, I'm just gonna outline this. So like this would be one of the square holes that's going through the first face of the cube. And so it says that the solid cube has a side length of 30 inches. And then it also tells us that this square hole is 2 by 2, so it would be 2 by 2, and then the width is still 3 because the hole goes all the way through the cube, and the cube has a width of 3, so the square hole would have a width of 3. And so I'm going to start off this question by finding out the volume of just the solid cube itself. And so that would be 3 cubed, so length times width times height, 3 times 2 times 3, which is equal to 27. And then I'm going to find out the volume of each square hole. And so that would still be length times width times height, so 2 times 2 times 3, which is 12. But this is just the volume of each square hole. But so how many square holes do we have in all? Well, at first you would think, oh, well, because there is 6 faces, that would mean that there's 6 holes. Well, in this case, because it says that each hole goes all the way through the cube, then that means that there technically is only 3 holes. And this is because, look at it this way. The square hole that starts on this side right here, this square hole, it would go all the way through, and it would end on the opposite side. But then the square hole coming from the opposite side, and it would come all the way to this side right here. And so if you see here, these two are actually the same square hole. And so the same thing applies to the side ones and then the top and bottom ones. It's the same hole going through. And so there's technically 3 square holes in all. And so we have 3 of these. So you'd also think, oh, well, it would be 27 and then minus 12 times 3. Well, we've actually overcounted because the middle section of the cube is actually overcounted because all of these square holes that's going through, so like, again, this going to the opposite side and then the opposite side coming back, it's all crossing over the same center cube inside the big solid cube. So that can be a little bit confusing, but if you think of it this way, because there are square holes that's getting caught from each side, so that means that the center part is actually getting overcounted. And so we have 3 square holes in all, and then you have to subtract the volume of the center square hole, and you have to multiply that by 2 because we're overcounting it twice. And so it would be 12 times 30, which is the original volume of all of the square holes, and then you subtract 2 cubed by it. You subtract 2 cubed from it, and that is the volume of the center hole, and then you have to multiply that by 2 because, as I said, it overcounted twice. And so this is the final equation, and now we just have to solve this. And so simplifying this, it would give us 27 minus, it would give us 7. And so therefore the answer is A. 7.